Hi there, this is Mr. Alexander, and today I want to briefly talk to you about solving rational equations, getting the x by itself in these equations. And the first thing you want to do when you're solving any of these problems is start by listing the restricted values, telling me what x can never equal, what's excluded from the domain. Now, in this case, you're going to want to look at the denominators of all the fractions and what makes them 0, because you can never divide by 0. So in this case, the denominator equals 0 when x equals 0. So I know that x can never equal 0. We'll keep that in mind as we're solving these. To solve this, what we're going to want to do is somehow get the x by itself. Now there's a couple of ways to do this. You can either combine these fractions by finding the common denominator, or you can multiply both sides by the least common denominator. I'm going to choose the former method. I'm going to realize that this is x over 1. And I'm going to make this a common denominator by multiplying the first term by x over x. Remember, you can multiply any fraction by 1 without changing the fraction. In this case, our fraction is just x. So the second term is still the same, but now the first term, when I multiply the top and the bottom by x, that's going to turn into x squared over x. Now in doing that, I've created a common denominator, so I'm going to put them over the same fraction, over x, but now the top is x squared plus 6. Now that helps me because at this point I can get the x by itself by realizing that this is a quadratic, and in order to have to solve a quadratic I need to have a 0 on one side. Now I can only do that after I get this x out of the denominator. I'm going to do that by multiplying both sides by x. And in doing so, these x's cancel out, and that leaves me with x squared plus 6 equals 5x. Now, like I said, to solve a quadratic, I need to have a 0 on one of the two sides. So I'm going to subtract that 5x over to the other side. X squared minus 5x plus 6 equals 0. Now, this thing is factorable. And the way I like to think about it is, what are two numbers that multiply to 6 but add to negative 5? Of course, that's negative 3 and negative 2. So I can factor this as x minus 3, x minus 2. Now to solve this, to figure out what x equals, I set each of these individual factors equal to 0. So x minus 3 equals 0, and x minus 2 equals 0. Of course, that means that x equals 3 and positive 2. Neither of those is a restricted value up here, so this is a solution. X equals 3 and 2. Moving on to a different kind of problem. This is another solving rationals problem here. And this may look familiar. This kind of looks like proportion problems you maybe had done in Algebra 1. And they're solved much the same way. The only difference is you want to first list the restricted values. I'm just going to use RV for that. So tell me what x cannot equal. Well, of course, you're going to look at the denominators again. And what values of x will make these denominators equal to 0? Here, a positive 1 will make that equal to 0. And here, a negative 4 will make that equal to 0. So I know that under no circumstances can x equal 1 or negative 4. Okay, well at this point, we're going to want to solve this. And a nice little thing you can do when there's one term on either side of the equal sign is you can just cross multiply. In other words, 3 times x plus 4 equals 2x times x minus 1. Like that. And what we're going to want to do is first distribute. So 3x plus 4 equals 2x squared minus 2x. And again, I'm seeing the squared term here, which tells me this is a quadratic. You can only solve quadratics by having a 0 on one of the two sides. So I'm going to subtract this 3x, and I'm going to subtract the 4. And what that gives me is 0 equals 2x squared minus 5x minus 4. And you may be looking at that saying, how do I solve that thing? How do I get the x by itself? I'm going to factor it, and I'm going to factor it by using the box method. Of course, I'm not going to do that yet because you may have noticed I've made an error right here. I apologize for that. 3 times 4 is 12. So that should have been minus 12 right there. That should have been a minus 12. And this should be a minus 12. So I've got 2x squared minus 5x minus 12, not minus 4. I apologize for that. Right over here, I'm going to use the box method. And put my 2x squared right here, and put my negative 12 right there. And we'll start with a times c, negative 24. 2 times negative 12 is negative 24. What are two numbers that multiply to negative 24, but add to negative 5? And I'm thinking that's negative 8 times 3. So those multiply to negative 24, but they add to negative 5. So I'm going to write my negative 8x here and my 3x here. So what do 2x squared and 3x have in common? Well, that's just an x. How about negative 8x and negative 12? Well, that's a minus 4. 2x squared and negative 8x, that's a 2x. And 3x and negative 12 share a common factor of a positive 3. So I can factor this thing as 2x plus 3 times x minus 4. Well, that gets me a little bit closer to the solution. Now I just need to set both of these equal to 0 and solve for x. So my x equals negative 3 over 2 and positive 4. I got that negative 3 over 2 by just setting 2x plus 3 equal to 0 and solving. Neither of these are restricted values, so we're in business. That is the solution. And that's how you solve cross multiplication problems. I want to show you one more. It's kind of challenging. And that'll be it. So let me get that for you. Here it is. There are two options for solving this problem. To get the x by itself, you can either multiply both sides by the least common denominator, or you can combine these two fractions by finding the common denominator and simplifying from there and cross-multiplying. I think since last time we combined and then cross-multiplied, I'm just going to multiply both sides by the least common denominator. So I'm going to take this entire thing and multiply it by x plus 3, x plus 5, x minus 5, sorry. And when that happens, so I've got 2 times x plus 3, x minus 5. And then I've got x times x plus 3, x minus 5 over x plus 3 minus 3 times x plus 3, x minus 5 divided by x minus 5. Now the whole point of doing that, so we can cancel those out, cancel those out. I'm going to go ahead and FOIL this out. That's going to give me 2 times x squared minus 2x minus 15. And here I've got x times x minus 5 minus 3 times x plus 3. I'm going to go ahead and distribute that 2 to give me 2x squared minus 4x minus 30 equals, distribute the x squared minus 5x, distribute the negative 3, negative 3x minus 9. Well, hopefully you can see this is a quadratic, so I need to get a 0 on one of the two sides. I'm going to get a 0 over here. I'm going to subtract that x squared over. That's going to give me x squared minus 4x minus 30 equals, I've got negative 8x here when I combine those two, and I still got that negative 9. And now I'm just going to add the 8x and add the 9. And that's going to give me x squared plus 4x minus 21 equals 0. So I need to go ahead and factor this thing. And to do that, I'm looking for two numbers that multiply to negative 21 but add to positive 4. That's, of course, is 7 and negative 3, so that's going to be x plus 7 times x minus 3 equals 0. And then I just need to set each of these individual terms equal to 0 to get x equals negative 7 and positive 3. But I skipped a step at the beginning. Did you notice? Up here, I didn't find my restricted values. Let's do that real quick. Look at the denominators. X cannot equal negative 3 or positive 5. Now, does that affect us at all? It looks like it shouldn't. Because this is a positive 3 and that's a negative 3, so it doesn't seem to make any difference what the restricted values are in this case. So we've got x equals negative 7 and positive 3 is our final solution. And that's how you solve that problem. So thank you for watching. I appreciate it, and I hope it was helpful. Bye now.